Hello, good morning. This is Naz from NB Network Lessons. Hope everyone is doing okay and in high spirits. My today's topic is going to be under physics with algebra, and we're going to do lesson 7. And in this lesson, what I'm going to do is I'm going to solve an example where we'll find what average speed is and we'll find what average velocity is. So basically, if you recall from my last couple lectures, I explained you the difference between distance and displacement. Distance is a scalar. What does scalar mean? Scalar means something which has only magnitude, does not have any direction. Displacement can be negative, can be positive, so that has direction as well as magnitude. So that is a vector. Average speed is just like you driving in your car. You're looking at your speedometer and you're saying 35 miles per hour. I gotta, go down. School zone is 20 miles per hour. So you're basically just looking at average speed. So that, my friends, is a scalar. Only has magnitude, no direction. Average velocity, however, does have direction. And I'm going to show you an example today in which we will find both of these, okay? So without any further ado, let's go ahead and get started. Let me draw and we're talking about one-dimensional motion, okay? So this is going to be one-dimensional motion. In between is my origin or 0, okay? And then I go 1, 2, 3, 4, 5, let's say go up to 6. All right. And then on the negative side, I go up to 1, negative 2, negative 3, negative 4. I go up right here. All right. This is one-dimensional motion. Now, initial point where you are right now, okay, has been given as xi is equal to 6. So you are right here. That is your home, okay? Your final point is -4, okay? Now that is your destination wherever you're going. It could be your school, it could be your church, it could be a shopping mall, whatever, all right? So now, what we need to do is we need to first of all find out what is average velocity. If you recall from my last lecture, average velocity is equal to delta x, change in x, over delta t, change in time. All right, that makes sense? So I've already explained you what delta is. Delta is a Greek word and it means change. You boil the water. You start from 20 degrees centigrade, okay? You keep on boiling the water and you come back in 3 minutes and you measure the temperature and it's 100 degrees. So the delta is 100 minus 20, 80. So that is what I'm gonna talk about. Delta x is your final xf minus xi over your let's say t initial, t final minus t initial. So what is my xf given? Xf is given -4, all right, and then initial is given 6. So -4 minus 6. Now what is my delta t? Delta t has been given as 6 seconds. 6 seconds. So in other words, in order to reach from your initial point, which is xi right here, to my final point, it takes me 6 seconds. So then that is going to be over 6. So then average velocity is equal to -4 Minus 6 is minus 10 over 6. I can simplify this further. I can divide numerator and denominator by 2. So this becomes minus 5 over 3. Okay? And that's meters per second. If you solve this further, you will get negative 1.67 meters per second. Now, what does this negative means? That is exactly what I was trying to tell you. That displacement, what we average velocity, in this case, is a vector. Because 1.67 is the magnitude. Right here, this is the magnitude, okay? So I'm going 1.67 meters per second. Negative sign tells me that I am going from right to left. My direction is this right here. So that is average velocity. It has a magnitude and it has a direction also. So my friends, average velocity. Now, I ask you to calculate the average speed, okay? So when you calculate the average speed, all you have to do, average speed, not average velocity, this was average velocity. Average speed is equal to absolute value of average velocity. What is absolute value of negative 1.67? It is equal to 1.67 meters per second. All right. So basically, speed does not tell me what my direction is. Average velocity does tell me what my direction is. Distance is just a magnitude. You know, you've gone 2 miles, you've gone 3 miles. I don't know what the direction is. Displacement tells me the direction also. Am I going from right to left or left to right in one-dimensional motion? And then I'm going to I've touched base already. I'm going to basically introduce you with something called instantaneous velocity. This is, let's say, point A, point B, all right? It takes you 5 seconds to get from point A to point B, so you're going like this. That's your average velocity, right? So, but instantaneous velocity is velocity at a particular instance. You might be going real fast and you reach in 3 seconds right here, and then you slow down and you might reach at your destination in 2 seconds. So then velocity taken at any given point, all right, is called instantaneous velocity, and we'll dive into that in my upcoming lectures. Thank you so much for watching. You all have a wonderful day. I will see you next time. You take care of yourself. Bye-bye.